So today, during the quiz, Miss McDonald, Miss Page, and I realized that we need to do some more work on word problems. So what we're going to do is we've broken it down, and we are going to focus first on how to write a proper and correct let statement. So the first thing, what a let statement is that it informs the reader for what you are looking for and what you have temporarily called it, which would be the variable. So each unknown needs its own let statement to indicate what you have been asked to solve. And oftentimes in the question, that last question that's in your paragraph, your word question, will ask you for exactly what you have to assign the variable to be. After you have written the let statements, translate the word problem into math, one phrase at a time. Today what we're going to be doing is starting with one-step word problems, and then the one phrase at a time will probably help you out when we get to two-step word problems. We want you to pay special attention to the wording of the problem. So this will mean that you have to read it a couple times, maybe even more than 3 times, to make sure you understand what the question is asking. Thank you. Make sure that it's you're looking at the key words. So if it uses the word sum means to add, like the answer to an addition problem. Difference would mean to subtract, and perimeter would mean that you have to add up all the sides of a shape or an object. If possible, draw a diagram or use manipulatives or act out the problem just to make sure that you fully understand it. Okay, and so we're going to go through. Oh, you have to scroll back up. Perfect. So we're going to look at this problem first. So after paying $9 for a pie, Riley has $94 left. Now, how much money did he have before buying the pie? So looking for the let statement, we need to find out how much money he had before buying the pie. So automatically, that's what our let statement will be. So let's let X represent the amount of money. The computer is being weird. He had before buying the pie. Alright, and feel free to go through and solve this problem. All of you are capable of doing that. Right now for this video, we're just going to focus on the let statements. So that's what you would write for your let statement, and then you would move on and write out your equation. Okay, so for this one, Esther is baking a cake. The recipe calls for 8 cups of flour. She already has put 3 cups in. So how many more cups does she need to add? So for this one, again, looking at this, how many more cups does she need to add? That's automatically what our let statement will be. So let's let X represent. I'm okay with this. I'm not sure if Ms. McDonald. Yep, okay. We're going to take a shortcut just because we're mathematicians and we like to be efficient. So let's, instead of writing out represent like I did up here, let's just say rep with a period. So let X represent how many more cups she needs to add. All right. So now we went through and we've written down the let statements. Now I'm going to help you translate the let statement and the word problem into an equation. I'm not going to solve the equation, we're just going to focus on this for now. So looking at this question, he has paid $9 for a pie and he has $94 left. So this is going to be what we let our equation equal. Oftentimes we want to make it equal X. Don't get into that habit. That's very few word problems will make it equal to the variable. We want the variable to be in the actual equation. So with this one, we're going to take x, subtract 9, will equal $94. So if you look at this, x is on, like, in part of your equation, and we're subtracting $9 because we knew that before he bought the pie, he obviously had more money. So this x will be a larger number than the $94, and then the total is equal to 94. Okay? Let's scroll down. Scroll down. I probably could. And for this one, so Esther is baking a cake. The recipe calls for 8 cups of flour, and she's already put in 3 cups. How many more cups does she need to add? So again, don't feel like you need to make it equal to x. If she's already put in 3 cups, let's start there. So it's going to be 3, and we know that the total is going to be 8. So we know that it has to equal 8, and because we let x represent how many more cups she needs to add, right away we know that it's going to be plus something to get your total of 8 cups. So that's our equation for that one. Alright, so this next question, we're going to write the let statement and the equation. And then again, we won't solve it. You guys are more than welcome to solve it at home though. So how many boxes of cereal can you buy with $15 when one box costs $5? So again, this is what the question is asking. So how many boxes of cereal can you buy when you have a total of $15 and you have each box is costing $5? So let's let x represent the number of cereal boxes. Are you okay with that as a short form? Okay. The number of cereal boxes. Okay, so if that's our x, we need to know if they have a total amount of $15, so that's the total. Let's let that equal $15. So our whole equation is going to equal $15. We know that each cereal box costs $5, and it depends on how many cereal boxes that you buy, how much you're going to multiply by 5. So if we say 5x equals 15, that's going to be the cost of the cereal box, how many cereal boxes you get. If you multiply those together, you will get the total answer, or the total amount that you spent. Okay? So that's the equation for that one. Okay, so how many packs of DVDs can you buy with $144 if one pack costs $18? So we're going to write this out as a division equation. So our let statement is going to be let's let x represent the number of packs of DVDs. Okay, so if that's what our x is going to represent, and we know that we have a total amount of $144, if we take $144 and we divide it by x, so remember x is the number of DVDs that we have, or that we're purchasing, it is going to equal how much each of those DVDs costs. Okay? So this is one example, and then actually if we scroll back up, can we scroll back up? This is a very similar question, which means with this question we could also write it as a multiplication question if we wanted. And either of them they're both right, and they're both, you can use both methods depending on what you prefer. So if we scroll back down, if we were to write this as a multiplication question, what we would do is we know that one pack costs $18, and we have assigned x to represent the number of DVDs that we're buying. So let's say 18 times x will equal, again, this is the total, which is $144. either of these are right and you can solve for x and it would give you the same answer. With my preference, this one is a little bit easier. So if you can try and make it into the multiplication version, that would probably help you out.